Have you ever stopped to think about what separates our living, breathing world from, say, the dead dust of the moon? I mean, the rocks themselves are surprisingly similar. The real difference is this slow, epic story that's happening right under our feet all the time. So let's dig in and uncover the amazing story of how dead rock becomes living soil. Okay, let's start here, on the moon. The rocks the Apollo astronauts brought back, they're made of pretty much the same stuff as Earth's rocks. But on the moon, that rock just gets pulverized into dust by meteor impacts, and that's it. It just sits there, sterile and lifeless, for billions of years. So what's the missing ingredient? Now, compare that lifeless moon dust to this description of our planet's soil, the ecstatic skin of the Earth. I mean, wow, it's poetic for sure, but it really gets at a profound truth. Our world isn't just covered in dust. It's covered in something dynamic, complex, and totally alive. And that brings us right to the heart of this whole thing. If the raw materials are basically the same, what process creates such wildly different worlds? How do you get from inert, dead geology to a vibrant, living ecosystem? Well, the answer is a process that's happening all around us, constantly, weathering. To really get this story, we have to start at the very beginning, with what we call the parent materials. Think of these as the three main families of rock that serve as the starting point for literally all the soil on our planet. And what's so fascinating is that rocks aren't static. They're not just there. They're always being created, transformed, and recycled in what we call the rock cycle. You see, an igneous rock can be broken down into sediment, which then gets squished together to become sedimentary rock, which can then get cooked and crushed into metamorphic rock, and on it goes. So, every single bit of soil on Earth started as one of these three rock types. You've got igneous, which is basically fire-born rock, cooled from molten magma. Then there's sedimentary, which is actually the most common type on the surface, kind of like a scrapbook of the Earth, made from tiny fragments of other rocks. And finally, you have metamorphic rock, the chameleon, rock that's been completely transformed by incredible heat and pressure deep underground. So how do we get from a solid mountain of, say, granite to something plants can actually grow in? Well, you can think of it like a two-act play. And Act 1 is all about brute force, the physical breakdown of big rocks into little rocks. This is what we call physical weathering, or disintegration, and it's pure demolition. Imagine taking a sledgehammer to a boulder. You're not changing what the rock is made of, you're just smashing it into smaller and smaller pieces. And by doing that, you're creating a massive amount of new surface area, which is absolutely key for the real magic that's going to happen in Act 2. One of the biggest players in this demolition job is water. When a river is full of sand and silt, it basically acts like liquid sandpaper. Over thousands and thousands of years, it can carve out massive canyons and just grind giant boulders down into pebbles and sand. But water has another trick up its sleeve. When it seeps into a tiny crack in a rock and then freezes, it expands with enough force to split that solid rock wide open. This process, called ice wedging, is just a relentless force in colder climates, prying apart entire mountains one flake at a time. And get this, even simple temperature changes can do a ton of damage. As a rock heats up in the sun and then cools down at night, its surface expands and contracts over and over. And this can actually cause the outer layers to crack and peel away, a process called exfoliation. It's literally like the rock is shedding its own skin. Okay, so we've taken our big rocks and smashed them into small pieces. But they're still just that, sterile bits of rock. So now we get to Act 2, where the real transformation happens. This is decomposition, the chemical process that turns rock into something totally new. We call this biogeochemical weathering. It's a bit of a mouthful, but it's because it involves biology, like acids from plant roots, and chemistry, all working together. And this doesn't just break the rock. It fundamentally dismantles the minerals inside and creates entirely new substances, like clay. This is where things get really interesting. This right here is a perfect illustration of chemical weathering in action. On the left, you've got a slate gravestone from 1798, still perfectly easy to read. But on the right, a marble one from almost a century later, and it's practically wiped clean. So what's the difference? Well, the calcite in the marble is super easily dissolved by even weak acid and rainwater, while the slate is way more resistant. So how does this actually work on a molecular level? Well, it's kind of like a three-step heist. First, water molecules attack the surface of a mineral. Then, Tiny hydrogen ions from the water actually sneak in and replace elements inside the mineral, like potassium. This completely destabilizes the mineral's whole structure, causing it to fall apart, releasing nutrients, and forming the building blocks for brand new minerals, especially clay. This chart really drives home just how transformative this whole process is. Look at this. When a granite rock weathers into soil, almost all of the calcium, like 99%, just gets washed away. But the concentration of iron nearly doubles. So you see, this isn't just about breaking something down. It's about completely re-engineering it. Elements are being sorted, removed, and concentrated to create a new material with totally new properties. So we've had the physical demolition and the chemical re-engineering. What happens when you put it all together? Well, you finally get the end product: soil. And soil isn't just one thing, right? It's this incredibly complex mixture. You've got brand new minerals like clays, which are amazing at holding onto water and nutrients. You've got the really stubborn leftovers from the parent rock like quartz sand. And you've got all those dissolved materials that become essentially food for plants. And that brings us right back to where we started. Weathering is the engine that drives this entire incredible transformation. It takes the sterile, raw geology of a planet, the exact same stuff you find on the moon, and turns it into the dynamic, complex, and fertile foundation for life. It is quite literally the difference between a dead world and a living one. So that's really the ultimate takeaway here. This isn't just some abstract story about rocks. It's a slow-motion epic being written constantly, everywhere on this planet. Every single handful of soil holds a history that stretches back for eons. So the next time you walk outside, just take a second and think, what incredible stories are being written in the ground right beneath my feet?